Hello, good afternoon, my friends. Let's look at this new question. And first of all, as I mentioned several times, we should firstly carefully read through the question itself. So this is a motor, and it is a induction motor. As we all know, for the AC motor, there are basically two types of motor. The first one is an inductance motor. The third one is a synchronous motor. Yeah. For this one, the speed of the stator is larger than the speed of rotor. So we should have a number of slip, right? Slip number, which is ns subtract nr, right? But for the synchronous motor, the speed of stator and rotor are the same. So the S value for synchronous motor will be 0, right? Okay. And for this induction motor, it has 4 poles. 4 poles means the pole pair is 4 divided by 2, which is 2, right? Okay. And we get all this value for R1, X1, R2, X2, and Xm. And this machine is powered by this source, and the line-to-line voltage is 400 VIMS, right? So as a star structure, this is a line voltage, which means for Y structure, the line voltage is square 3 of phase voltage, and the line current is equaling to the phase current. Okay, let's look at the question A. It gives us the value of slip number, which is 5%, and let us draw the equivalent circuit of the inductor motor. So I think this answer is quite straightforward because basically the structure for the induction motor is the same as a transformer, right? And the very bottom physical law behind all these things is Faraday's law, which is EMF equals minus N d phi dt, which means the varying magnetic field will generate the electrical field. Okay, so let's draw the equivalent circuit. So it should be like this, right? So this is R1, which means the total resistance for the wire in the stator. This is JX1. X is a reactance. Don't forget this thing, right? This is the impedance. This is the resistance. This is a reactance, right? Reactance includes two things, which is inductance and capacitance. Okay. And this is a GXM, and this is RM. All these two parts come from the inductance by the wiring circuit current or wiring voltage. And this is R2, this is JX2. For this part is rotor, for this part is stator. However, we get the equivalent circuit, but it's difficult for us to calculate it because there are two parts, right? So we just combine these two parts into one circuit, which should be like this. right? This is still R1, GX1, GXM, RC, but here we should to convert the rotor part into the stator part. So it should be like this, okay? And here it's GX2 like this. This is from the mathematical deduction. Yeah, you can get it the material way from the textbook. We don't do it here. Okay, that is this is a equivalent circuit. But in our question, it said neglecting the resistance of the core. So we don't care about the RC. What does it mean? It means the value of RC should be much larger than the value of XM. So the parallel value of these two things is very close to XM. So we just neglect to choose the RC. All right, I think here we can get the result for the first one. So we just make it like this. This is GXC. So I think this one is a required circuit for our question here, right? Yeah, it should be like this. Be careful about these two parts. It's A and B. At the left of the A and B, it's a stator. At the right side of A and B, it's a rotor. All right. So the secondly, it asks us to calculate the stator line current. All right. So we want to get the current. The first law coming into our mind is the Ohm's law, right? It should be V divided by Z, because now we have, inductance. So it's not R, it's Z. Yeah. How can we get the result? So first of all, we should make our equivalent circuit much easier, because this is R1, GX1. We can make them into one form, which is Z1. Z1 equals R1 plus GX1. And here is Z2, right? Z2 equals R2 like this. Okay? So after this operation, we can get our circuit like this. Z1, Z2, GXM. Okay? So the total current should be like this. Firstly, the Z2 and the GXM, they are with the relationship of parallel. So Z parallel equals Z2 parallel GXM. And the total impedance in this circuit is Z1 plus Z parallel, which is like this, right? Z2 plus GXM, Z2 times GXM. So we can get the material expression for Z1, which is R1 plus GX1, which is 0.45 plus G 0.9. The unit is ohm. Z2 should be like this. 0.9 divided by 0.05. This is S plus G 0.9. And GXM equals 25J ohm. So we just put all this material value into the equation. So I just skip over the calculation part. After some material calculation, we can get the value of Z0, which is 6.6 plus 3.46 J ohm. And we can convert this form into our phasor form, which is square root 6.6 square plus 3.46 square, and the angle is theta. So how to get the value of theta? tangent theta equals 3.46 divided by 6.6. So finally, we get the phasor form of Z0 is 7.45. The angle is 27.667. All right. So now we get the value of V. Okay. The line voltage is 400 volts. Okay. Because our structure is star structure, the phase voltage is the line voltage divided by square root of 3, which is 400 divided by square root 3, which is 230.94 volts. So finally, we can get the expression for the total line current in the stator, which is like this: the phase voltage divided by the total impedance, which is 234.94, 0. Why we set the angle 0 here? Because we use the phase voltage as a reference. So we just input the expression of Z0, which is 7.45, 27.67, and the answer is like this. Okay, the unit is ampere. This is the final result for the line current in the stator. It should be like this. Thank you.